Alright guys, we are now going to, as you can see here, going to be using our calculators, our graphing calculators. So make sure you're with somebody who has a calculator. If you don't have yours, you need to have yours obviously at this point, and the test we take this week requires it. So make sure you have this and you are practicing together. Again, if you don't have yours today, take turns practicing this process. It really does help to actually physically hit the buttons yourself instead of just watching me on a computer, okay? So anyway, to get started here, what we're going to be talking about is a concept called quadratic regression. Obviously, that's the title of the lesson. Now, if I really want to quickly summarize this whole thing, here's what we're going to be doing. We're going to be taking a list of data, and we're going to be putting it in a graph. And when we put that data in a graph, say we have like time as our x value, and let's say we're dealing with money. So we got money as our y-axis, and we're talking about how much money we have over time. So when we or maybe even just the economy, how much money our economy has had over time. So what you would do is you would start entering amounts based off the time. So for instance, let's say this first time represented 1900. And we go by, say, like 50 years at a time, and we start just labeling data. So we'd have like 1950, 2000, and then what we would do, and this is a very short version, but we'd be able to possibly go out to 2050 here in a minute, but we would start with some data here. So let's say we had a dollar amount, and then later we had another dollar amount, and actually going by 50 years would be a little, not enough data, but let's just say we had lots and lots of data, okay? So maybe we did it every year or whatnot, and we just had lots and lots and lots and lots of data. And when you put this data on a graph, you don't have an equation. You have data that kind of goes like this, and what happens is you start to get some sort of shape here. Obviously, this would maybe be a country that has started to not do very good, and may want to know, like, okay, when are we going to run out of money? Well, what we can do is take this data, and if we want to figure out exactly or try to predict when we're going to run out of money, is we do something is we kind of fit a curve to the data. And that's called, this curve right here is called a regression equation. And it's also called a curve of best fit. I don't know if maybe, and I have it labeled here because you should have hopefully seen this at some point, maybe in Algebra 1, where you learn about finding a line of best fit. This is the same thing, it's just a curve now. We can do quadratic functions and other polynomial functions. We can fit, based on what the data looks like, we can fit whatever curve we really want to it. This would be a quadratic curve, for instance, and our calculators are able to do that. Now, if you have a graphing calculator on your phone, more than likely, unless you have a TI or a Casio emulator, more than likely it's not going to do this regression concept. You need to have a professional graphing calculator or an emulator that emulates these professional graphing calculators. So that's what we're going to be using. I got to show you that process. It does take a few keystrokes. It's not just 2 or 3 steps. It takes multiple steps. But overall, what we're going to do is this. We're going to find these points. We're going to label those points in our calculator, so our calculator is able to graph it. Once we have those points all found and labeled, then what we're going to do is we're going to calculate a regression equation, and then we got to copy and paste that regression equation into our graphing utility. The y equals screen, and then we can go ahead and do whatever we need to do with it. Find the vertex, find what equals 0 or a specific amount or whatnot. So up here, and we'll be using this quite a bit. I'm going to go through these steps. I'm not going to focus on it too much right now, but all the steps are listed right in this chart. So that's how you enter your data and how you find that curve. But I'm actually going to even add a couple steps to that, to how we copy and paste that equation into our y equals screen. So you're going to see a couple extra steps. You may want to write those steps down. Again, you have the luxury of pausing the video if you need to when I talk about this stuff. So what we're going to do here, we're going to talk about how to do this, and we're going to start with example number 1, and we have some data. This data represents an amusement park ride. It takes riders to the top of a tower and drops them. So the table below shows the height of the tower at time t seconds after the drop. So this is going to be, again, at 0 seconds, we're at 200 feet, 0.5 seconds, we're at 164 feet, and so on. So this is, kind of like a Tower of Terror, or actually Tower of Terror goes up and down, up and down. Maybe trying to think of Orlando here, what, Dr. Doom's Death Drop or something, Universal, something that just goes straight down. So you can kind of get an idea or visual what's going on here. So here's what we're going to do. On your calculator, first thing we're going to do is we're going to enter your data. So the steps are up here, but you're also going to see me do it. So you can kind of see my cursor here. And obviously we're entering some statistics. So we're going to go to the stat screen. So you're going to go stat. I should probably turn this on first. That'd be a good idea. So I'm going to go stat, and we want to edit that data, so we're going to hit enter. Okay, and you get this screen right here. Now this screen, the L1, I want you to think of the L1 as your X values and the L2 as your Y values, and that's what the screen says as well. So we're going to go ahead and enter this data. So we're going to start with our X value, so 0, hit enter, 0.5, hit enter, 1, enter, 1.5, and 2. So those are all our X values. Now we're going to come over here and hit plug in our Y values. So 200, 164, and you can hit enter or down. Sorry, I just kind of do either one. 120, 68, and 8. And just to make sure this doesn't give me anything screwy here, if it has this extra line, I hit enter on accident on the last one. You can hit delete and it should go away. Otherwise, let me plug this back in. I want to make sure I do this right. So we have 0, 0.5, 1, and so on. Because what will happen, and it should be fine either way, so this is probably just a waste of your time because it does it on both ends. If you accidentally plug in, say, one extra value on your X or your Y axis, or you forget a value, skip one, it will give you an error when you go to try to graph this. So if you get that error, go back to that screen and make sure that those lines match up. You have the exact same amount of data on your left and your right hand side. Okay. So now that we've entered our data, what we want to do is we want to calculate that data. We want to make an equation. So this is where we go to the second set of steps right here, where we find the curve of best fit. So to find that curve, we're going to go stat, and then we want to calculate. So we're going to hit that right arrow over there. And in this case, if you look at your data right now, our data is going to be quadratic. If you don't know that, let me actually jump back here for just a second. What we can do is we can get a look at this data in our graph. I'm going to show you how to do that right now. So if you go to y equals, you have this little thing up top here that says plot 1. Well, some of you actually had some error messages because your plot 1 was highlighted and I told you to unhighlight it. Well, we're going to highlight it now. So bring your cursor up to the top here by hitting the up arrow and hit enter. And before we end up graphing right now, I want to get our window right. So our window is going to be based off these points that we currently have in our table, and you'll look at your Y value, it goes up to 200. So my Y values, actually I'll start with my X values. My X values go up to 2. So I'm going to go 0 to 2. And then I'm going to, actually let me go to 5, just so I can, because we may have to go beyond that. But we can see everything there. So 0 to 5, so that makes it big enough where I can see everything. And my Y values, and my scale is good. My scale is 1. That means every tick mark is going to mean 1 unit. My Y values are going to go from 0 to 200 because that's as high as it gets, and it goes down from there. So I don't need to go any higher. And at this one, just to make it so I don't have a ton of tick marks, I'm going to make my Y scale 50. So that should give me 4 tick marks. And now I can go ahead and graph this, and you'll see that data right here. Okay. Now this data, we have, it's really asking what equation would best fit it. That's what letter A is asking. Now in that case, you can fit two possible things to this. You can fit a linear model or a quadratic model. Because it looks mostly linear, but it looks maybe see a little curve there. If you don't, that's okay, because your answer is going to be very, very, very close to the same when you go to end up calculating some data here. But just for the sake of argument here, we're going to do a lot of quadratics and other polynomials. So we go to Stat, Calculate. I'm going to do a quadratic regression, which means I'm going to fit this to a quadratic model. So I'm going to go down to option number 5, and you notice that's what we're mostly doing in this lesson, is just quadratic regression. So that's the one we're going to be using, and we're going to hit enter. And you may get, depending on what screen you get, you may get this, but if you do, just hit enter. It's L1, L2. It's already set up under the right list. So hit enter, hit enter. We have to hit it a couple of times, and just go to calculate. And it's going to give you your equation. So you have an equation now, and that equation is going to look like this. It's going to be y equals, and a is -16, so -16x squared, plus bx, so -64x, plus 200. And you'll kind of see some of the things that match, like your y-intercept is at 200. This is just dropping you, so there's your gravity coming into effect. So you can kind of see all this data fitting. Now again, sometimes data doesn't fit perfectly, so you might get like -15.98 or something like that's close to -16, because that's because if you aren't calculating the data accurately, then obviously your answer is going to kind of show that, or your equation would show that. But that's this one works out pretty good. Okay, so you have two options. Now, you got to get that equation into your graph screen. So one way to do that is to type it in just as it is. But sometimes your answer isn't going to be so pretty. And you may get some really crazy numbers, and it's just a pain to copy all these down. So there's another way to do it. So here are these steps that I recommend that you write down. The first step, when you want to copy this, obviously you're in your y equals screen for this to happen. Step number 1, hit this vars button, variables. You hit that. Once you get there, honestly, you should be able to kind of figure out what you should be hitting next, all the way up to the final step. But here's what you hit. Next up is statistics, because we were just in the statistics screen when we got this equation, so that should make sense. So you can hit the 5 key, or you can scroll down. Next up, we want to go to equation, because we were trying to find our equation here. And notice the first option that pops up is our regression equation. Let's hit enter. And it's going to copy that equation into the screen for you. Again, you can type it in, but sometimes you have really long decimals, and this just is really convenient. Okay, so now when we go to graph, we should be able to see our graph fitting that data fairly well. So there's your quadratic equation fitted perfectly to the data. Okay, so now you got your equation. Now we want to know, how long will it take it to reach the ground? So we want to calculate when it actually touches 0. So this goes back and a little bit of review, but this is where we go second, calculate, and we're going to calculate the 0. So let's go ahead and do that right now. I'm going to go second, calculate. I want to calculate my 0. I want to know when it hits the ground, or how long it takes it to hit the ground. Right now my cursor is at 2.5, -60. So I need to hit the left key to get that point up so that it's greater than 0. Because right now, notice it's saying left bound. So I want to find a point to the left. So see my cursor, it's kind of flashing in there. Notice I am to the left of the 0, which means I'm going to hit enter. Now it wants my right bound, so I'm going to hit my cursor until, notice my y value has gotten to be a negative value. It doesn't matter how far I go, that's fine. But now I'm definitely to the right of the 0. My 0 is less than 2.18, so I can hit enter now. And now it says guess. So I'm going to go ahead and get as close as I can here to that 0 at -1.6. Hit enter. And I'm going to, how many seconds will it take to hit the ground? It's going to take approximately 2.06 seconds to hit the ground. And that is how you use the regression equations. Okay, so once you have this, you can do lots of different things in terms of modeling. So those are the examples I'll be given. Is I'll show all the different types of things you can possibly find once you have the equation. But notice we didn't start with an equation. That's what's kind of cool about this. We took data, we created an equation using data, which is normally how things are actually presented to you in real life. You're not just going to be given an equation and say, solve this equation. You're going to be given data, and there's going to be things that you're like, you know what, we need to figure this out, or we need to figure that out. So you take the data, you create the mathematical model, and then you analyze that model. And that's what we're doing. That's why this is kind of one of these cool things that I'm definitely not skipping. You need to learn this. You're actually applying some mathematics. So next up, we're going to do two other problems here. Oh, sorry, that's my phone. We're going to do two other problems, and let me answer my phone, and actually I'll get back to do those. But we're going to do number 2 next. All right, and then on number 2, this one's going to be very similar. This is a great one for you to maybe pause and try to go through these steps, and then because I'm going to go through it a little faster, assuming you've kind of done it already. So try this one on your own. It's very similar again to number 1. The question for part B is a little different. So again, try to use logic. Don't just say, oh, I'll just blindly copy whatever Mr. Patrick writes in his paper. I want you to think about this one, how we could find how long it'll take to reach a height of 150. And then we'll kind of go through that as well. But let's get that equation, pause the video, and then you will see what I get. Okay, so what you should be doing when you get this equation, you're going to go obviously stat and edit. We want to edit this data, and we're going to change the data we had before. You can hit clear, or sorry, delete. You can delete all this data like this. You can type over it, or you can hit clear from the very top and hit the down arrow, and it'll clear it all at once. Whatever you do, don't hit delete at the very top, or else it'll delete the entire table. Now I'm sure there's a way to get that table back. The only way I know to get it back is to go to second, memory, and you have to reset your memory. It's the only way I know to get it back. I'm sure there's another way, but you reset all your RAM and just keep following the directions, and it'll clear it and start over. So I mean, that's one option if you end up deleting your table, because that'll screw a lot of stuff up here. But we're going to go back here, stat edit. Let's type in our data. So we got 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. And then I'm going to go to my y values and type in 480, 482. And then we got what, 452, 390, and 296. Okay, so now that I have my data, I'm going to go into my equation here, and you can literally let's get your window set up. Notice again I highlighted plot 1. I'm going to set up my window from 0 to let's go 0 to 8. And I just want to make sure I can see this whole graph. If I need to go a little bit bigger, I just want to see it even hit the ground and all that stuff. So I'll go by ones. That's good. My y values, though, I'm going to start at 0. And it looks like I'm going to go all the way up to maybe 500. And this one's going to have a scale maybe of 100. And that'll allow me to see my y values. So if you hit graph, you should see those data points. And you see it kind of coming down. You got that quadratic curve going on. So now what we need to do, we're going to go hit our stat 1 here, and we're going to calculate our regression equation. So we're going to go stat calculate, and we're going to go down to quadratic regression. So hit 5. Hit enter a bunch of times, and there is your regression equation. So your equation is y equals negative 16 x squared plus 18x plus 480. So we got our equation. Now to get it on our graph, go to y equals, hit vars, or type it in. But you can go vars statistics, go over to equation, and then hit enter for regression equation. So now we have our equation typed in. All right, So now that we have it, we can graph that. You should see it kind of fit those data points fairly well. And I want to know when it's going to reach a height of 150 feet. So when you're looking at your graph here, this represents your height. And the 150 is somewhere right in there. So here's how we're going to figure out when it reaches a height of 150. Go to y equals, go to your second equation, and type in 150. What it's going to do, it's going to graph a horizontal line at 150. Now, when this horizontal line intersects your quadratic function, you are at the point t, comma, 150. Again, I'll say that one more time. This point right here that I'm hovering over is t, comma, 150. And that 150 represents the height. The t is how long it will take to reach that height. So again, your equation, what I'm doing here, just to give you a visual, we have our graph, we have our second line, and we're trying to find that intersection point at t150. So to do that, to find that point, we're going to go second, calculate, intersect. So let's go ahead and do that now. Go second, calculate, let's find the intersection of those two graphs. So notice it says first curve. What it does here is wants to know what two curves you want to find the intersection of. Well, there's only two curves, so you should only have to just hit enter. It'll automatically jump to your second curve. There's no other curve for it to jump to, so we should be fine. And now, once you hit enter that second time, it brings up the question guess. So we're going to scroll over here to that point as close as we can get it, and we're going to hit enter. And our intersection point is approximately 5.138, so 5.14. So it takes about 5.14 seconds here for that. In this case, I didn't even read the question. He jumped off a cliff into the ocean while vacationing in Hawaii. So it took him about 5.14 seconds to reach a height of 150 feet. So that was a big drop. I think he's 5 seconds. He's still falling. That's, yeah, I wouldn't do that. But anyway, if you did it, that's how long it would take, just so you know. So anyway, that is number 2. And those setups on those are pretty similar. So the last one that I'm doing for you guys is going to be down here. It's going to be number 6. So number 6, notice has a little bit of different setup in terms of your table. So here's what we're going to do with this table. I do not want to type in on this table 2005 for my x values. What I want to do instead is I want to kind of reset those numbers to something a little bit more feasible, like this. My actual t values that I'm going to use, instead of 2005 for my x value, which would be insane, I'm going to call my first value, let's see what they're asking here. Okay, yep, I'm going to go ahead and do this. I'm going to call this first value 5. And what I'm doing is I'm saying t equals 0 represents the year 2000. So that way I don't start my graph at 2005, because that would be a crazy looking graph if you were thinking about it. We're going to start at 5 instead. So I'm going to call this 5. And then this next point would be 6, 7, 8, 9, and 10. So again, we should be able to model that a little bit better. The answer shouldn't be as crazy. But you will notice your equation on this one won't be pretty, because they're not dealing with a constant like gravity. So now when I go to do this one, we're going to go stat, edit, and we're going to type in our data, and we're going to start with 5. We're going to go from 5 to 10. So 5, 6, 7, 8, 9, 10. All right, go over to your y values at L2, and we're going to type in our, in this case we haven't even talked about the problem, so this table below shows the average sale price of a house in Norfolk, Virginia in thousands of dollars during these years. So understand when you type these in, they're in thousands, so it's 158,000. We'll remember that when we go in to type our final answer in, but we can type it in as 158. That'll be fine now as long as we remember to convert it. And then 145, 132, 130, 138, and 142. So we got our home prices. And again, this is something that would be really useful because you always want to track, sales price of homes over time to kind of see if there's any trend you might be able to see, especially if there's certain trends when you happen to have, recessions like we had in mid 2000s. Maybe you can help predict some of those as well. But anyway, we got our data, and again, last time what I did is I went over here, I got my window. You can also just get your equation first. The order that you do that doesn't matter. You can either find your equation first or you can set your window up first. This time, just to do things a little different, I'm going to go ahead and find my equation first, and then I'll type it in and get my window. So I'm going to go stat. I just hit stat, and I'm going to go to calculate. And just like we did before, we're going to do our quadratic regression. So hit that, hit enter a bunch of times, and we have our equation. Now you notice here this one is not as pretty looking. This is where you really want to be able to use that copy and paste feature. So I'm going to go to, and I do want to write the equation. I will write a simplified version of that equation on here on my screen. So I have 3.017, I'll just call it 3, x squared minus 48.2x, and then plus 323.9. Now one thing about data and trying to analyze real data, the more accurate you can be in terms of writing your equation, the more accurate your final answer will be. The sooner and the more that you round, the farther away your final answer will be from the actual value you need. So I'm a huge proponent of using the actual values, which is why we use the copy and paste feature. We don't just copy this equation into our screen. We're going to type this actual one. So here's how you do it. Go to y equals. We can clear that real quick. I'll even clear this other one real fast. The plot one we can keep because we re-entered the data, so that data's automatically been repopulated because we just copied over the old data. So we're good there. But we're going to go vars, statistics, equation, regression equation. And we have our equation copied. And it's a little crazier now, but like I said, we didn't have to worry about typing that all the way in, so we have it. Okay, so now before I graph this, now I could graph it, but it would look kind of weird. We need to go to our window, and remember we started our graph at 5, but I'm going to go from 0, and I want to know if you look at part B right here, it wants to know the house value in 2015. So I'm going to go out to 15 just to make sure. Actually, I'll go out to 20 so it's not right on the edge of the screen. I should be able to see 15 on there. So I'm going to go there, and I'm going to go up by 5s, I guess, as my scale. Doesn't really matter, but it does look better that way. My y values, I can probably just go from like 125 to 160, but just to see the entire thing, it's okay to start at 0. I'm going to go up, though, it looks like, to the highest price we saw was about 158. So let's go to 170, I guess, just to make sure I see everything. Again, you don't have to do exactly what I'm doing. I'm just trying to give you some ideas. And this one, maybe I'll go up by 50. Okay, so again, I just want to make sure I can see everything. That's really what I'm doing with my window. There's not one right window. This is just the one I chose. So now I should be able to see my entire graph, and there it is. Okay, this is everything I need to see. Obviously, it looks like this would go a little bit farther, but for now we're good. So we have our equation. We want to predict the house value in 2015. So when I want to predict that, understand I want the point 15 comma blank. Remember, this is our home price. This is our money. Okay, so here's a reminder of how to do that thing. One thing you can do, you can go to your table and you can scroll. And you can scroll down to 15. Now let's say we had to find out 223.5 or something weird. If we have to predict a value that's not a nice whole number, this only gives us whole numbers. So this is where you go to your second and you go to your table setup screen. And we want to change this, and I like you just to keep it in this form because this is, we won't have any issues when we get to change our independent variable to ask. What this does, it changes our table where it doesn't just give us all the values, we get to type in whatever values we want. So I'm going to go to my table and I'm going to ask, I want to plug in 15. And again, when it does that, it'll tell me the price in 2015. So the price in 2015 is about $279.71. And again, to get the actual price of that home, remember this is in terms of thousands of dollars. So this is going to be $279,000. So 279 and then 710,000. We just put it in terms of thousands. So that's going to be your average home price in 2015. Now, if you paid attention to the market, that's probably fairly accurate. I mean, if you really look at how home prices have increased, because we had like a little recession in the late 2000s, mid to late 2000s. I know because I bought a house then, and home prices have gone way up since that bottomed out. And it was actually, I think it bottomed out in like 2010, 2011, but just to give you an idea, it's fairly accurate though. I mean, those home prices have exploded. So this did model it fairly good. So anyway, that is going to kind of be some of the things you're going to be asked to do. The main thing you need to know how to do at this point is find the equation. You need to know that process. Once you do that, again, notice there's all these different things I can ask you for, and I try to kind of vary the scenarios, finding zeros, find an actual y value, and then find an actual x value. That's what I did on these three examples. Again, this first one that I did, finding a 0, finding an actual x value. Notice I was looking for the x value if given a y value. And the last one, we were looking for a y value given an x value. So I kind of flip-flopped it on you. So the last thing I did that was a little different on this example is, again, if you're given crazy data like this for your x values, just go ahead and change that. Change those numbers so that they're smaller, so it fits better on your graph. And you can adjust that however you want. Just make sure like the distance is the same. Now, if it's something like this, if you want to keep those, that's okay. But like when you're talking about the year, usually if you're talking about years, reset that so your graph doesn't start way out at 2000. Just imagine drawing a graph and your first x values at 2005. That would be kind of hard to graph. So that's why we kind of change it. So make sure you're doing that as well. But even here, I'll probably change that to 0, for 20. But you can do what you need to do with that. So anyway, that's what we have. I'm going to show you real quick our homework. Okay, so here's the homework. You have Unit 4 Homework 10. Now this is going to, first off, we're not doing the whole thing because we've actually done some of this already. But this is going to be due tomorrow. I'm going to be checking this off in class that you completed this assignment. That includes actually answering the whole question, not just throwing numbers down. I want to see what you did. So that I want the actual equation. Like write down as much of it as you can when you get those crazy numbers. But the only ones we're going to be doing in Unit 4 Homework 10. Again, I'm going to go ahead and post this assignment separately so it's easier to find in eCampus. So you should be able to find it fairly easily in eCampus. I'll even label it Quadratic Regression Homework. But you go down to this assignment and we're only going to do 6 and 7. Those are the only regression equations that we have. They're the only ones that have data. So we're just going to go ahead and do just those two problems. Okay, so again, Quadratic Regression Homework on eCampus, 6 and 7, due on Tuesday. So make sure you're getting that done. Okay, so go ahead and give that a shot. If you have some time in class, do it then. If not, go ahead and practice this. You have the video. You can kind of go back and watch the steps. And also remember the steps, the main steps that we're doing are listed right in the notes right at the top. So kind of follow through that process. If you're still wanting some extra assistance with this, feel free to, YouTube has a lot of videos that you can kind of watch that goes through this process as well. This is a fairly common process. So go ahead and give this a shot, and I'll see you guys tomorrow.